Okay guys, in the last examples of this video, what we're going to do is tie it all together by taking each of the equations given and writing them in all three equivalent forms. Once we have all three equivalent forms for each quadratic, we will then be able to find the vertex, the x-intercepts, and the y-intercepts. So we're going to get started with number 8. Now number 8, you might notice, is already in standard form. So that form is already complete because that's the form it was given in. Sometimes I know when standard forms look like this, students get a little confused because they're used to seeing 3 terms. So the way I know this is standard form is because it has no parentheses. So when it doesn't look exactly like ax squared plus bx plus c, but if you notice there's no parentheses in the equation, we can think of that as standard form. We also want to understand that c in this equation is 0. Okay, so because this is a standard form equation where the c value is 0, it's an extremely easy one to factor because all I will have to do is factor out a greatest common factor of x. So because it's easy to factor, I'm going to go ahead and translate it into intercept form first, because that's all you really need to do to go from standard form to intercept form is simply to factor. So I'm going to write that down here. Factor the equation to get it into intercept form. Okay, so we have got x squared plus 6x and then plus 0. Because there's no number without an x, each term has an x, and therefore I can factor an x out from each term, leaving me with 2 factors, x times x plus 6. So that one is in intercept form simply because it is factored. That's why you can also think of intercept form as factored form. So this one reveals to us the x-intercepts. So far we know the y-intercept from standard form and the x-intercepts from intercept form. Really quick, when you have your factors, you can take each factor, set it equal to 0 to solve for your x-intercepts. This one's already done. So when you have a factor of just plain x, not adding or subtracting anything else, you know that that'll lead to an x-intercept of 0. When you have a factor like x plus 6 and you set it equal to 0, you end up having to subtract to solve for x, so then you get a 0 or an x-intercept that has the opposite sign from what was in the factor. I think I might start keeping track of some of these answers down here. You may want to do something similar on your paper, some kind of answer key, but so far we know from standard form that the y-intercept is 0, 0, and we know from intercept form that the x-intercepts, there were 2. There was 0, 0, and then negative 6, 0. So to get the vertex, we're going to have to translate into vertex form, so I'll do that here. Now, there's 3 ways we could do this, because there's just so many ways to find the vertex. I think I'm going to do the completing the square just to review that process one more time, and also because it's a really easy one to do that with. It's missing the c value, which is nice. I don't even have to worry about subtracting that. It's got an a value of 1, and the b is even. So why not just complete this square? So remember, to complete this square, I take that middle number, b, I divide it by 2, and then I square the result and add that number to both sides. So I've basically completed the square on the right side, and then on the left side I'm just balancing out the equation by adding that same perfect square to both sides. Now we factored this one earlier, so we know that x squared plus 6x plus 9 will factor into x plus 3 quantity squared, since 3 plus 3 is 6, and 3 times 3 is 9. All I have to do now is simply move the k value back to the other side, subtract the 9, and voila, I am in a vertex form. So I have x plus 3 squared minus 9. That is my vertex form. So here we had all 3 forms. Standard was the one we were given, was x squared plus 6x. Intercept form was when we factored it, x times quantity x plus 6. Vertex form is when we had completed that perfect square and got x plus 3 quantity squared minus 9. I can now see from the vertex form that I have a vertex of negative 3, because remember h is opposite sign, and negative 9. So I'll keep track of that down here on my little answer key. And that was example 8. Now with number 9, I can see that this one is already in vertex form. I can tell because it has the set of parentheses squared. So I'm not going to need to complete the square or anything on this one because it was already done. So I'm going to have to convert into standard form and then from there into intercept form. To convert to standard form is simple. I just FOIL out that perfect square, distribute, and combine like terms. I'm going to have you guys do that right now. So upon FOILing out x minus 4 times x minus 4 and distributing the 2 and combining like terms, we end up with y equals 2x squared minus 16x plus 24. Since everything's been FOILed out and all like terms have been combined, this one is in standard form. Now that we're in standard form, we know the y-intercept. The y-intercept is going to be 0, 24. Also back here from vertex form, we knew the vertex would be positive 4, negative 8. All we need to do now is factor the standard form to get it into intercept form. So we factor to get standard form into intercept form. So to factor this one, I'm going to start by noticing that each of these numbers are even, so I can factor a 2 out of each of them, which will make the rest of factoring simpler. With the remaining trinomial, I notice the a value is 1, which is also a nice, easier version for factoring. So I just need to find two numbers that multiply to 12 and at the same time add to negative 8. So in order to multiply to a positive and add to a negative, both of the factors are going to have to be negative. So for this one, it turns out to be negative 6 and negative 2. Since the a value is 1, I can just go straight from finding these numbers to putting them in factored form, x minus 6 times x minus 2. So this factored version is intercept form. So now that I'm in intercept form, I can easily solve for my x-intercepts by taking each of my factors, setting them equal to 0, and solving for x. So I have one x-intercept of 6 and another x-intercept of 2. So let's write down all of the pieces of information that we were able to find. So we were given the equation in vertex form. So the vertex was 4, negative 8. We were able to distribute that to get standard form to see the y-intercept of 0, 24. And after factoring and setting each factor to 0, we found that the x-intercepts were 6 and 2. And then just one little thing I wanted to point out is notice how the a value is the same for all of these. Intercept form had an a value of 2, standard form had an a value of 2, and vertex form had an a value of 2. So that's a connection between all three. Now for the sake of time, because you might notice this video is quite long, we are going to go ahead and skip number 10 because we already had an example where we started in standard form, so we don't really need another one. So we're going to skip that one and go straight to number 11. 11 gives us an equation in intercept form. How do I know it's in intercept form? Because it's got those two factors. It's got the two set of parentheses being multiplied together, indicating two factors. So we know this one is already in intercept form. So we can just take each of those factors, set them equal to 0, and solve to find my x-intercepts. So with the first one, I start by subtracting 1 and then dividing by 3. So I have one x-intercept at negative 1/3. For the second one, I add 5 and I have my second intercept at 5. Now to go from intercept form to standard form, that's the next easy one to go to because all I have to do is FOIL. So I'm going to have you guys go ahead and do that right now. So after FOILing out the two factors from intercept form, I get my equation with no parentheses, which is standard form. And so from that one, I can find the y-intercept. Also, now that I'm in standard form, I know that a is 3. I know that b is negative 14 and c is negative 5. What this can help me do is it'll help me find the vertex so that I can also convert this one into vertex form. So we're going to use the formula negative b over 2a to find the vertex and go from there. I will have you guys do that right now. Okay, so using the formula negative b over 2a to get the vertex would end up being negative 14 over 2 times 3, which is positive 14 over 6, which gives 7/3. When I plug 7/3 into my equation for x, I get 3 over 1 times 7/3 squared minus 14 over 1 times 7/3 minus 5 over 1. Remember, when I'm working with whole numbers and fractions, I put my whole numbers over 1. Simplifying that out, I end up getting negative 64/3, which is my k value for the vertex. 7 over 3 was my h value. So when I plug everything into vertex form, and remembering that a was 3, I get y equals 3, quantity x minus 7/3 squared, minus 64/3. Remember, in the formula, h always comes after a subtraction, so though h was positive, in the equation it comes after a negative, so it's x minus 7/3 squared. So now that I have all three forms, let's keep track of the information we have. So starting with the vertex, we know from vertex form that h is 7/3 and k is negative 64/3. In standard form, we saw that the y-intercept was negative 5. And at the very beginning of this problem, when we were given the factors, 3x plus 1 and x minus 5, we saw that the x-intercepts were positive 5 and negative 1/3. So that concludes this set of video notes. Thanks for watching. See you in class.